Today we're going to be working on finding the equation of a tangent line. This is from the topic differentiation. And this is just applications, one of the applications of derivatives. Derivatives can help you find slopes, and we use slopes to find the equation of a tangent line. And the question we're using today says, consider the function f of x is equal to 4 over x plus 2x to the power 4 over 5 minus 2 over 5. Calculate the value of the function at 2, right? So if we find the value of your function at 2, that just means on your calculator, you're going to substitute 2 in the place of x, right? So it's going to be 4 over 2 plus 2 times 2 to the power 4 over 5 minus 2 over 5. So if you go on your calculator and go into the run matrix, you're able to put that on. So it's 4 over 2 plus 2 times 2 to the power of 4 over 5 minus 2 over 5. And the answer is 8. So the value of your function at 2 is 8. Then the second question says, find the value of your derivative at 2. So that is, first we have to find this derivative, and then we'll substitute 2 into the derivative. So let's go to the options we have here. Let's see, let's go to calc. Yes, that's where the derivatives are. And then we go to d over dx, that's the derivative. And then you can put your function in that bracket that just opened up. So remember, your function is 4 over x plus 2 times x to the power of 4 over 5 minus 2 over 5. And remember that the value of x that we're substituting is 2. Okay, so that gives you 59 over 5. So these two values that we just found are actually really important in helping us find the equation of the tangent line. So the first value that you found gives you a point. So from here, you get a point. That's what you need when you find the equation of a tangent line. You need a point. And the point that we got from there is 2, 8, right? When x is 2, y is 8. And the second thing you'd need to find the equation of a straight line, because that's what a tangent is. Your curve could look like this, and then the tangent is going to be a straight line that touches your curve at exactly one point. In this case, ours is touching the curve at the point where x is 2, right? So that's what a tangent is. It's a straight line. So the second thing we need is a slope, and you get that from your derivative. The slope at 2, when x is equal to 2, we'll call it m. It's 59 over 5. So that's what the next part of the question says. A line L is tangent to the graph at the point 2. Find the equation of L. and give your answer in the form y is equal to mx plus c. So then what we have right now is a point and a slope. So we're going to use what is called the point slope form of an equation of a straight line, right? Of the equation of a straight line. Some people call this a slope. Some people call this a gradient. It's just one word that refers to the same thing. Slope, gradient, it's the same thing, right? So the point slope form of the equation is you're going to do y minus y1 equals m times x minus x1. Remember, m is your slope, right? You get m from your slope. And then you get x1 and y1 from the point that we got in the first question we worked out. So that's x1, that's y1. That's where you get them from. So let's substitute them here. So it's going to say y minus 8 equals 59 over 5 times x minus 2, right? And then we're going to expand the bracket on the right-hand side. So 59 over 5 times x is just 59 over 5x. And then 59 over 5 times 2, can work that out on your run matrix, over 5 times 2. Remember, the number that's outside the bracket needs to multiply every number that you have on the inside of the bracket. So that's 118 over 5. So what I basically did was 59 over 5 times x, and then I did 59 over 5 times 2. The number outside the bracket multiplies everything inside the bracket. Okay, then the next step is to add 8 to both sides, right? If we're adding 8 here and adding 8 here. That's because I'm trying to undo this minus 8 that's here, because the equation is supposed to say y is equal to mx plus c. Y is supposed to be isolated on its own. So I need to remove anything that's on the same side as y, right? So that is why I'm adding the 8 to undo this 8 that's already subtracted here. You undo subtraction with addition, right? So that's going to say y is equal to 59 over 5x minus 118 over 5. And like I said, I'm adding 8 to both sides, right? I'm going to add 8 here. And the effect it has is it gets rid of the 8. And then we have to do the same thing on the right side of the equation to maintain the balance. Okay, that's what happened there. Then that means we're doing negative on your calculator. You're going to do negative 118. Why am I saying negative 118? Because that's the sign that's in front of 118 over 5, right? So negative 118 over 5 was 8. That's negative 78 over 5. So y is equal to 59 over 5 x minus 78 over 5. So that's it. That is the equation of the tangent line, this right here. Then it says the graph of y is equal to f of x and L have a second intersection point at A. Use your graphic display calculator to find the coordinates of A. So now that we have those two equations, you can go back to your menu and go to graph. The first thing that we're going to graph is going to be the function that we got at the start. So that said 4 over x plus 2 times x to the power of 4 over 5 minus 2 over 5. That's the first one we're going to graph. And then we're also going to graph the straight line, the tangent line that we found, whose equation we found just now. So that would be 59 over 5x minus 78 over 5. So now we can draw those two on the same graph. Do you see that? See, they touch each other. We can clearly see that. But it says that they touch each other, they intersect at more than one point. There's a second intersection point, but I can't see it here. I can only see the intersection that happened at 2, but I can't see any other intersection point, which means I might need to change the view window. Let's include some negative numbers. Go to 20 with a scale of 2, and think on the y-axis also need to include some negative numbers. Okay, there we go. See, we also change the view window. On the y-axis, just going to start at 50, stop at 50. Let's see this one as well. Start at 50, negative 50. Stop at 50 and count in 5s. Just try and make sure it can show us everything we need to see. Okay, that's a bit better. I'm going to count the y's in 5 as well. Move that. Oops, I keep moving the actual calculator. The scale should be 5. Okay, that should do it. It's a bit better. Then we can go to GSolve and find some intersection points. Okay, that's the one we're looking for. Intersects at negative 0.22, negative 18.2. Yeah, so the coordinates of A, according to the graphing calculator, were negative 0.224 and negative 18.244. And then there's also the other one that we already knew was there, the 2.8, right? The one we were given by the question. Okay. Thank you for watching this video. See you next time.